So what I want to go over here is just a couple of situations that people are running into. First one has to do with number 5. Okay, in single replacement reactions, I'm seeing the number on oxygen or sulfur or whatever the nonmetal is, because oxygen is special. Agreed? Okay, when it's by itself, it's special. When it is in a compound, it is not. And we have to swap and drop. Now it's in an ionic compound. This number here, it only applies to oxygen when it's by itself. It isn't carried over to the other side. Everybody follow me? I'm just seeing that happen on several people's sheets. Okay. So it's a single replacement reaction. Sulfur special, so it gets an 8. This is -2. Iron over here was +2. Okay, so it's +2 on this side. So FeO is our formula. The numbers on special molecular elements do not carry over when they are replaced or put into a compound. All right, everybody follow me there? Okay. Other things I'm seeing here, once in a while you'll have something like number 7 where molybdenum oxide reacts with hydrogen gas. Okay, now hydrogen special, it's written here as H2. Okay, so molybdenum oxide is going to be MOO. What's the most common charge? What's the most common charge on molybdenum? Is it 6? Okay, so MO3 then. Okay. Plus hydrogen gas. When hydrogen is a gas in a reaction like this, what kind of reaction is this? Single replacement. It acts as a metal. Okay, so it should be replacing molybdenum. Okay, giving us okay, everybody with me there? And then you balance the reaction after that. Okay, so just little things that we hadn't essentially covered yet. Okay, that we need to maybe just talk about quickly. Okay, so special elements numbers don't carry over to the other side. You have to reswap and drop when they enter a compound. Hydrogen generally behaves as a metal when it is by itself. Okay, so it should replace your metals in replacement reactions. Colton, question? Oh yeah, you have to balance them both. I was just showing you the exceptions. Okay. Yeah, so to balance, you got 8 sulfur, so you go 8 here, 8 there, 4 there. Okay, and then for this one here, 3 oxygens, 3 hydrogens. Yeah. Okay, making sense there, guys? Okay, so those are just a few that I'm seeing here, and people are calling me over. And don't forget, anytime you see 8, ite, okay, things like that, they're usually polyatomic ions. Right? Once in a while I am seeing people put C for carbonate when it should be CO3 for carbonate. Okay, just little things. Right? But it looks like in general we're getting the hang of this. Okay, just 2 things here, guys. The first 2 questions, and I think I briefly mentioned this yesterday, but I'm not sure now. Okay, there's actually 2 correct answers for both 1 and 2 here. It depends on how you wrote water on the reactant side of the equation. You could have potassium reacts with HOH, which would give you KOH and H2, and then you'd have to go back and balance like this. But you could have also written water as H2O, but that gives you different products when you do that, and it's fine. Either one of these would be correct on a test. Okay, and that one, okay, we just needed 2 here. In actual fact, both of those things happen when potassium is thrown into water. Okay, the reason that the metals here in group 1 are so reactive and so dangerous is because very explosive hydrogen gas is produced when they're thrown into water. So this reaction does happen, but very quickly it dissipates down and you get a basic solution of KOH, okay, and H2. So, all right. And then for calcium, same idea. It depends how you decided to write your water. If you wrote it as HOH, okay, then you got CaOH2 plus H2, and then you just put a 2 here. Or if you wrote it as Ca plus H2O, then you would have got CaO plus H2, and that one's already balanced. Again, both of those things essentially happen when that reaction occurs. So both would be keyed correctly on a unit exam or quiz. Okay. One other thing here that I've had a couple of people ask about has to do with when you have ammonium in a double replacement reaction. People aren't sure what it's acting as. Okay. The answer is, look at the charge. Ammonium's positive, like all the metals are. Positively charged things behave like metals. People were confused about what to do when they had a compound that contained two polyatomic ions. So if I have barium chloride, okay, looks like this, reacts with ammonium carbonate, NH4 and CO3. When I swap and drop that, this is a -2 and this is a +1. So I actually have NH4, 2, CO3. Now, which one of these two ions is positively charged? The NH4, right? The ammonium has got a charge of +1. Now, that means it's behaving as a what? As a metal, because all metals are positively charged. Okay, so if you have two polyatomic ions in a compound, and the only time you'll have that is if you have ammonium, because ammonium is the only positively charged polyatomic ion, it behaves as a metal. Okay? That is a double replacement reaction. Okay, so you swap NH4 with barium. Okay? All right, keep working on those guys. Give them a try. Okay, and we'll go through any that give you trouble. Guys, on number 10, you'll notice I give you the products on number 10. Okay, reason for that, it's not a type of reaction that we've gone over, so there was no way for you to identify the type and as a result predict what the products would have been. So I've given you the products for that one. Just write it out and balance it. Okay, okay guys, another one that's coming up a little bit here. I've had several people ask me about it, so it's just a quick review of swap and drop kind of rules. Special situation for swap and drop. If I have molybdenum sulfide, all right, so I've got MOS. Okay, this is -2 and this is +6. All right, so I've seen people going, all right, 6 and 2, but what do I do on an ionic compound if I've got something I can reduce? Then I reduce it. Okay, so this actually reduces down to MOS3. Okay, on an ionic compound, you should always reduce to the lowest terms after your swap and drop. All right, it happens so rarely that it's not surprising. It's, you know, that we only talked about it once. You forgot the rule. Okay, but just make sure that you remember that there's two right in a row where that situation applies. Okay, but it's so rare. Okay, you hardly ever have to do it. Okay, one other one that's coming up here, guys. On number 7 and any other time where you see this happen, if an ionic compound is in a single replacement reaction with hydrogen gas, is hydrogen acting as a metal or a nonmetal? It's acting as a metal. All right. Why? Where does hydrogen appear on the periodic table? On the left side with the metals. The only time hydrogen is a nonmetal is if it's in a compound and it's listed second, third, fourth, anything other than first. Okay, most of the time hydrogen behaves as a metal. Okay, when you see it in a reaction. All right, so if it's something is reacting with hydrogen gas in a single replacement reaction, hydrogen is a metal in that case. All right, so number 12 here, guys. We got silver nitrate, AgNO3. Okay, that's swapped and dropped correctly because they're both 1s. This is a -1, that's a +1. Reacts with copper 2 chloride, Cu, which is a 2+, reacting with chlorine, which is a -1, so we get CuCl2. All right, what kind of reaction is that? Double replacements, 2 ionic compounds. So we swap the metals, and we're going to end up with copper with nitrate, silver with chlorine. Okay, these are both ionic compounds, so what do I have to do with them? Drop and swap and check them to make sure they're okay. Well, this one's okay because both of these are 1s, so AgCl is right, but copper is not right with nitrate. So nitrate's a -1, this copper was a +2. We were told that on this side of the equation here. All right, because it was a 2 and it was with chlorine. So when I drop and swap, I have to put brackets around the nitrate and put a 2 outside. Now, what do I do? Now I balance. I can start with nitrate or copper, it won't matter which. Okay, I need to put a 2 here to make my nitrates work. That gives me 2 silvers, so I go over here, gives me 2 silvers and 2 chlorines. That balances my chlorines. There's 1 copper on each side, so it's balanced. Okay, remember guys, if you can't get it to balance, what do you need to check? Your drops and swaps. Chances are you missed one. Okay, number 10, yep. All right, so copper 1 sulfide, Cu with S. This is -2. This one's +1 this time, Cu2S. Okay, reacts with oxygen gas, O2, to form copper 1 oxide, CuO. This is -2 +1, so it's Cu2O. Okay, and sulfur dioxide, SO2. All right, again, this was the one where I had to give you the products because there's no way you would have predicted them. It's not a typical reaction type. Well, it's kind of a complex replacement. It's not really a classification for it. All right, so starting out here, I can look at sulfur. I got 1 on each side. The problem is that I've got 3 oxygens over there, and I've only got 2 over here. Okay, how do we solve that problem? Double everything. Okay, so let's start here then. All right, so that gives me how many sulfur now? 2. Okay, so I can put a 2 there. Gives me how many copper? 2. So I need to put a 2 there. That got rid of my odd problem. Okay, so my sulfurs are balanced now, and I have 2 times 1 is 2, plus 4 more is 6. What times 2 will give me 6? 3. Okay. Everybody with me there? We've talked about that odd-even problem a number of times, right? Anytime you have an odd number of something on one side, and it's usually oxygen, okay, and an even number on the other, put a 2 in front of the first thing and rebalance, and it'll almost always work. Okay. Any other ones? All right, keep going then, guys. Monday, we're going to be in the lab, so be aware of that. You need to wear the proper footwear. All right, so no flip-flops, open-toed sandals, shoes, or anything like that. Okay, make sure you have shoes that cover your feet. If you're going to wear loafers, you got to wear socks in them at least. Okay, I know that's going to look really silly, but okay. And remember, don't wear your best duds. Okay, it's not picture day on Monday, so you don't have to worry about that. It's not even retake day on Monday, so wear something you won't miss. Some of the reactions that we will have are vigorous. Okay, and we do not want them to spill onto you. Okay, so make sure you dress appropriately for Monday for the lab. Okay, all right, keep working on that, guys.